Hello everyone, welcome to this video. So today we are talking about server sent events. Let's see what they are and get our hands dirty with little Go code. So imagine a very common scenario that you need to send a push notification to some mobile, or you have a website showing live football scores and you need to tell each browser or each user connected to your website that there has been a goal. Now you see, in these scenarios, the communication is just one way. It's just from the server to the client. The client is just receiving the push notification and then it can take whatever action it wants. But it is not actively communicating in real time with the server. So for these scenarios where the server needs to have one-way real-time communication with the client, we need server-side events. Clear? Now let's see how the communication protocol actually works. So server sent events works using HTTP itself. Look at this diagram. So the client first sends a common normal HTTP request to the server on some endpoint. Let's call it the stream SS. Now the server responds back with some header set in its response. The most important one of these headers is the content type header. The content type is set to text/event stream. This tells the client to keep the connection open so that the server can send it more stuff. So now, after both of these exchanges has been done, the request and the response, the server can now send messages to the client till the connection is closed. Now, if the connection gets closed, the client again has to do that same HTTP request on that HTTP endpoint to re-establish that connection again. But one thing to remember here, guys, that this does not work with HTTP 1. It only works with HTTP 1.1 because there only we can have persistent connections, right? So this is the basics how server sent events are actually working. Is just a simple HTTP exchange and then the server can send in all their messages. Nothing fancy, nothing very complicated. Okay, now let's get our hands a bit dirty and do all these things that we discussed in some simple Go code, right? Let's see what we are trying to build first. All right, so here you can see I have got two browser windows which has opened the same web application, right? And you can see that it is displaying a random number, the same random number every few seconds. So this is actually a server sending them both a random number every 3 seconds or so, as far as I remember, and it is using server sent events. So before explaining the code, I want to thank this blog post where it took a lot of code from. This would be linked in the description, so please do go and check it out. So let's take a look in the Go implementation. Okay, so this is the Go implementation. I won't live code this thing. I would just explain you the code, because why take the trouble of writing the code again when you have already written it once, right? Okay, so we have got this broadcaster struct, and okay, let me give you guys the fair disclaimer that you need to understand a little bit of Go to understand this program. So you see this broadcaster struct, right? So this has kind of some state and some channels to help in our program. So what it has is this channel called broadcast, which helps us broadcasting the messages. So whenever anyone send any event on this channel, it would be broadcasted to all clients. That's what it meant for, right? There's this new connection channel which would be taking in new connections, and you see it's a channel of a channel. I'll show you how it is happening in a few minutes, right? And the closed connections is also a channel of a channel. And at last we come to the connections. So this is a map which has a channel which takes in a byte array and int 32, right? So what this means is that every connection that we have would be actually represented by a channel. That's why you see new connection and closed connection are channel of channels. This channel, when we send something to this channel, it is meant to deliver it to that particular client or that particular connection. And I will show you how it is all implemented, right? And this int32, the value would actually be a sequence number, just a monotonically increasing sequence number for the clients. You can just have it a Boolean or something else also. I just kept it a int32 for some reason. Okay, now let's come to this function called listen. So this would be run as a Go routine. And what it will do, it will listen on these channels. Now, whenever there is a message, right, on the broadcast channel, what it will do is it will send this message to all the connections. And as I told you that each connection is represented by a channel, and we are sending the message to that channel, right? So this will make sure that our message will go to that that particular client. And how will we deliver this? I'll show it to you. Okay, now let's come to this one. This is when a new connection is coming up. So whenever a new connection come up, we put it there, we give it the sequence number, and then we increment the sequence number. Simple. And then we have a log line, and then there is for the close connection channel, we just delete that connection from that map. So you understand, right? Every client is represented, or every connection is represented by a particular channel. And we need to implement the next parts in such a way that on sending some message to each channel, that message is actually delivered to that client. So we need to handle that networking now, right? Okay, now I've got some like maintenance function like new broadcaster and all these things to simply create this broadcaster object. So we have this server struct, which will just have this broadcaster. And herein we will implement the HTTP functions, which will actually handle that first HTTP request from the client and then set up all our further networking. And then I have a maintenance function to create this server object and call broadcast.listen using a go routine, right? Okay. Let's go to this serve HTTP function. This will be the endpoint where the user will be requesting, or the client will be sending the first request, and we will be actually setting up everything here, right? So first I create a flusher object to flush all the data in the writer, right? So now I'm calling this function called set headers, right? Let's see what this is. Now here I am putting all the headers for the connection response. Okay, so you see in Go, if you don't know about it, so in Go you see this, we accept as a part of this HTTP handling call, we accept a response writer and a request. So the request will have all the details of the request that the client send us, and the response writer, this will be whatever we write in this response writer will be actually sent to the client, or whoever is sending this HTTP request to us. So what we are doing is in the write response, or this response writer, we are setting these headers. Now, as I said, the content type must be set to text event stream, and these are some other headers that we are setting, including this connection keep alive, to let the browser know that we want to have a long-term connection, or we want to have that connection not closed, right? And this access control is just to avoid the coarse problems. Okay, now what we are doing here is that, as I said, every connection represented by a channel. So I create that channel and I'm accepting a byte array there, right? Now what I'm doing is I'm telling the new connection channel that, hey, I have a new connection. So now it would be added in the broadcaster. Cool. Then I have a defer function, which means that this function would be called after this function has been completed. So this is just to clean up, and we are just sending this channel to the close connection channel because close connection is a channel of channels. So we are sending this channel there, and we just want to inform the broadcaster that this connection is done with, and you can remove it from your map, right? As I showed you in the listen function. Now what I want to listen for is if the request is done. So if the request has been disconnected, or if the client has disconnected from the server. So at that time, I want to just close the connection. I'm just waiting for it, and I just want to close that connection. And at the end of the function, we have this infinite for loop. What we do here is we are waiting for anything to come in the client connection channel. Each connection is represented by a channel. We added this channel to our map in the broadcaster. Now, when the broadcaster sends anything into this channel, it's our responsibility now to send it to that client, right? So for this client, whoever has connected to this endpoint right now, this is the channel, right? Because we just created it right now. So we are waiting for this, and then when any data comes in, we will simply write it in the response writer using fprintf, right? Now we are also sending in this string. So in server send events, you always have to send back a string, a UTF-8 encoded string, and that always has to start from data : right? And there has to be a space. So this is the mandatory prefix that you have to do for SSE, else it would not work, right? I mean, I don't know how these web standards were written, so don't ask me why do we have to append data. Maybe there is some story, I don't know. If you know, write it down in the comments. Okay, so right, so whenever anything comes in, we are writing this string to the writer, and then we are flushing this write stream. So this makes sure that whenever something comes in, we are waiting for it and we are sending it to that proper client. And in the main function, I have just done some setup. So I have done this listen and serve on localhost 8080, giving this server, right? This would basically handle our HTTP server, and I have written this function called start pinging, and I have given the broadcaster. So what the start pinging will do? So this start pinging will actually have a ticker, which will give this tick every 3 seconds. And whenever we receive something in the ticker, we will actually broadcast a random number. Now you see, to create this message, I am just taking a random integer under 10, converting it to a string, and then converting it into a byte array, right? And I'm just sending it to that broadcast channel. So it will be broadcasted to all the clients we have. This is all of the server implementation, nothing fancy. Okay, and just don't look at the LLD of this thing or how I have implemented the structures and the functions, or if this code is clean or not. This is just to explain a simple concept, and let's keep it at that. Don't put this code in production, you will be fired or something, right? Don't blame me then. Right, now we are done with the server code. Let's see the simple client code that we have, which is not much. So in the client, in JavaScript, we'll have to create an event source, and in event source, we have to give the endpoint that we want to create. So this would let us accept all server send events, this event source. I still have this console.log here debug message. I forgot to delete it. This is so embarrassing, man. Okay, I'll just let it be there. No one uses debuggers. We just use console logs, right? Okay, now what we do then is we hook our function to the onMessage function of the event source. So every time there is a message from this endpoint, this function will be called, right? So what we are doing is just a simple console log, just to like for debugging purposes. And then we are setting the inner HTML of this div. And I know this is bad JavaScript or bad front end. Please excuse me for that. I just wanted to demonstrate something or the other, right? So I'm just setting the inner HTML directly to message.data. So this data parameter would contain your actual data, and there will be a lot of metadata along with it in this full message object, right? I've written some fancy CSS to make this look good. And at the end, we have our simple web application, which is taking in events from the server. So you see this random number could well be a push notification from the server, and you can accept it, right? Cool. So is everything like hunky-dory and kumbaya in this server send events? No, there are some drawbacks to it, and we should know about them, right? So let's take a look at the drawbacks. So the first obvious drawback is that it's one-sided communication, right? The client cannot actively communicate with the server. If you need something like that, you can use WebSockets or something like that. That will be better. The other thing is that it can only have text payloads. So you cannot actually give a binary message or a binary payload through a server sent event. It will only accept UTF encoded text, so no small images or small audio, nothing like that, right? And I also read it that the number of connections is limited. I didn't try it though, but I read it on a blog. I'll link it in the description, that the number of connections is limited. Why this happens is that you get a limited number of connections from your client to that particular domain. I forgot what that exact number was. I think it was around 6, but yeah, that was that. So the number of connections is actually limited to that particular site. Actually, you know, for these kinds of problems, like similar problems like this, Uber moved their push notifications architecture from server-side events to gRPC, and I plan to make a video about that. So maybe sometime I'll do that. Okay, so this is all I had for this video. Leave a like and subscribe to the channel to help me grow. And if you want more content like this, please put in the comments what you liked and what you didn't like, and do correct me if I was wrong anywhere. I can be wrong multiple times because I am not very smart, Okay, so see you in the next video. Bye.